Welcome to Module 2 of the Sustain 3D Fashion, Environmental Sustainability and Circular Economy, Benefits of 3D Printing. In the next minutes we will explore the principles of sustainability, analyze the transition from traditional to circular business models, and examine the role of 3D printing in creating innovative, sustainable fashion. We will also address the environmental challenges associated with 3D printing and encourage critical thinking on how to balance innovation with ecological responsibility. By the end of this module you will acquire a robust theoretical and contextual understanding of environmental sustainability concepts and circular economy models. The role of 3D printing in advancing sustainability and circularity and the environmental challenges of 3D printing. So what is environmental sustainability? Environmental sustainability means managing natural resources responsibly to maintain ecosystem balance and protect the rights of future generations. It's about using what we need, without compromising tomorrow. So now let's move on to the three core principles that guide environmental sustainability, which are conservation, pollution prevention, and intergenerational equity. These principles are interconnected and vital for balancing human well-being with the long-term health and sustainability of ecosystems. The first principle, conservation, means the careful management and preservation of natural resources, biodiversity, and ecosystems. Its goal is to maintain ecological balance and protect these resources so they remain available, healthy, and sustainable for future generations, ensuring long-term environmental stability and resilience. The pollution prevention principle focuses on strategies and practices that minimize or eliminate waste and pollutants at their source. It protects human health and ecosystems from hazards while applying the polluter pays principle, making polluters responsible for the environmental and social costs they cause. The intergenerational equity is the ethical principle that today's generations must safeguard a planet as healthy, diverse, and productive as the one they inherited. Its goal is fairness and sustainability, ensuring future generations can access and benefit from Earth's essential resources equitably. These principles relate directly to UN's Sustainable Development Goals, particularly Goal 12, Responsible Consumption and Production, and Goal 13, Climate Action. These SDGs promote shifting to sustainable resource use, improving energy efficiency, and adopting sustainable consumption and production patterns to protect the environment and combat the negative impacts of unsustainable practices. Further, the EU Green Deal and Circular Economy Action Plan drive a shift from linear to circular systems, targeting climate neutrality by 2050 through reduced pollution, resource efficiency, material reuse, recycling, and biodiversity restoration for future generations. Now let's explain the circular economy, which replaces the linear, take, make, dispose model with a regenerative system that aims to eliminate waste, keep materials and products in use for as long as possible, and regenerate natural ecosystems. The circular economy follows three key principles. First, design out waste by rethinking how products are made. Second, keep materials in use as long as possible through reuse and recycling. And third, regenerate natural systems by restoring what we've taken, ensuring healthier ecosystems and sustainable resources for the future. These principles shape how we move from traditional linear practices to more sustainable systems. By applying them, we can transform not only products and processes but also the entire economic model on which our societies depend. This transformation shifts us from a linear model to a circular model. Linear model, take, make, dispose, means that resources are extracted, turned into products, and discarded, causing depletion and environmental harm. Circular economy. In this model, materials flow in loops, being reused, repaired, or recycled, minimizing waste and conserving resources by closing the loop. Building on the principles of the circular economy, a range of innovative business models have emerged to make these ideas real. They focus on designing out waste, keeping materials in circulation, and regenerating natural systems by embedding circularity into supply chains, production processes, and customer relationships. The first model is the circular supply business model. This model replaces traditional inputs with bio-based, renewable, or recovered materials at the design stage. By sourcing sustainably from the outset, companies ensure materials don't end up as waste. Known as cradle-to-cradle design, it mimics natural cycles and turns products at end of life into new production inputs. To give an example, we can look at the luxury fashion brand Stella McCartney, which exemplifies the circular supply model. In partnership with biotech firm Bolt Threads, it integrates Milo, a mycelium-based leather alternative, into its designs. This collaboration shows how high-end brands can adopt innovative materials to eliminate waste and reduce environmental pressure from their supply chains. With regard to the circular resource recovery model, this one focuses on collecting and processing existing waste to create secondary raw materials for reuse. Essentially, the supply model is about reducing the demand for new resources by changing the input materials, whereas the recovery model is about creating resources from waste to displace the need for new resource extraction. An example of resource recovery business model is a Spanish-based textile innovator with the name Recover, using a business model which is built entirely around resource recovery, thus transforming textile waste into high-quality recycled fibers, which are then spun into yarns used by major fashion brands. Let's move now to the third business model, the Product as a Service (PaaS) business model. Here, products are offered as services rather than sold outright. Companies retain ownership, design for durability, and support repairs, upgrades, and reuse. As an example, we can mention the Patagonia's Wornwear platform, which exemplifies the product as a service business model, enabling customers to repair, trade in, and resell used gear, shifting focus from new sales to longevity and customer relationships. We've seen how circular business models drive new ways of sourcing, designing, and selling. The next step is understanding how production itself changes. Moving from traditional manufacturing to sustainable production puts circular economy principles directly into factories, supply chains, and technologies. Traditional manufacturing follows a take, make, dispose model, heavy resource extraction, mass production, and waste disposal. It prioritizes cost efficiency and volume over ecological considerations, resulting in high energy consumption, fossil fuel dependence, long supply chains, transportation emissions, and limited product lifespans with little repairability or transparency. On the contrary, sustainable production embeds circular economy principles into every stage of manufacturing. It designs out waste, keeps materials in use through recycling and reuse, and regenerates ecosystems. This approach reduces demand for virgin resources, cuts emissions, and ensures manufacturing contributes positively to the environment. Now let's move to the key pillars of sustainable production, which include resource efficiency that includes fewer, renewable materials and minimal waste. Design for longevity that includes repairability, reuse, and upgradability. Closed-loop systems involving recycling and remanufacturing at end of life. Local and digital production, which includes shorter supply chains, lower emissions, and cleaner inputs, which leads to renewable energy and non-toxic materials. Advanced technologies, also especially additive manufacturing, 3D printing, make sustainable production practical. Additive processes use only the material needed, reduce overproduction, enable customization and localization, and support on-demand manufacturing, turning the principles of a circular economy into real-world practice on factory floors. Building on circular business and production models, the next step is to see how technology accelerates change. 3D printing, additive manufacturing, aligns with circular economy principles by reducing waste, improving resource efficiency, and enabling on-demand production across sectors such as fashion. Fashion has a heavy environmental footprint. 10% of global carbon emissions and 20% of wastewater stem from linear production. 3D printing offers a promising alternative by rethinking how clothes and accessories are designed, produced, and consumed, replacing mass overproduction with sustainable, digitally driven methods. Traditional garment production wastes 20 to 30% of fabric through offcuts and overproduction. 3D printing builds items layer by layer using only the necessary material. Designers like Danit Peleg show how biodegradable filaments create zero waste, customizable garments directly from digital files, bypassing cutting and sewing. In this way, 3D printing can lead to reducing waste and enabling resource efficiency. Additive manufacturing also supports the circular economy by enabling on-demand, made-to-order production. Brands like Zellerfeld and platforms like DressX allow customers to personalize designs and download 3D files locally, reducing unsold inventory, warehousing, and global shipping emissions while extending garment life and customer satisfaction. 3D printing also reverses traditional long supply chains by enabling distributed, local production hubs. Products are made close to consumers, reducing transport emissions. Colors can be embedded in the filament, eliminating water-intensive, toxic dyeing processes and lowering the overall environmental footprint of fashion manufacturing. Further, many startups like Reflow transform post-consumer plastic waste into recycled filaments for 3D printed fashion items. Bio-based materials such as PLA and thermoplastic starch further embed circularity. Research shows e-waste plastics and sustainable photopolymers can also become inputs, enabling repair, remanufacturing, and true closed-loop production. 3D printing in fashion offers new sustainability opportunities but also raises environmental challenges. This section explores 4 key issues: energy consumption, material waste, limited material options, and social behaviors that shape the real environmental impact of additive manufacturing in fashion. The first challenge is the energy consumption. Advanced 3D printing methods like laser sintering or fused deposition modeling often demand substantial energy. If power comes from fossil fuels, the resulting carbon footprint may offset sustainability benefits, particularly in regions with carbon-intensive electricity generation. Secondly, although additive manufacturing minimizes off-cut waste, thermoplastic filaments used in 3D printing may not be biodegradable or easily recyclable. Failed prints and support structures can also add waste unless effective recycling and recovery systems are implemented. However, efforts are underway to improve sustainability through optimizing software, using recycled materials for new filaments, developing reusable support structures, and implementing circular economy models. Most 3D printable fashion materials are petroleum-based plastics with high environmental impact. Bio-based or recycled options exist but remain limited and face technical challenges, restricting large-scale sustainable production and delaying broader adoption of greener materials. Limited materials in 3D printing fashion constrain designers, as most options are rigid plastics or require specialized, high-tech polymers, unlike traditional textiles. While flexible materials like TPU and bio-based plastics exist, they can lack the desired comfort and performance, with ongoing research focused on developing sustainable and multi-material options to achieve the desired aesthetics and durability. In addition, fast fashion culture and consumer appetite for rapid trends can undermine sustainability gains. Without education and awareness, 3D printed fashion risks repeating overconsumption patterns rather than fostering durable, responsible, and circular consumption habits. Now let's see what we've learned together. We've seen how the old, take, make, dispose, way harms resources and why moving to a circular approach really matters. We've learned the 3 big ideas behind circularity: design out waste, keep materials in use, and give nature a chance to recover. We've also looked at real examples of circular business models showing how companies are already putting these ideas into action. We've also recognized the hurdles, like high energy use, limited eco-materials, and the challenge of changing consumer habits. Most of all, we've learned that 3D printing can be a real driver of circularity when it's combined with smart design, clean energy, and people who value sustainability. Thank you for learning with Sustain 3D Fashion Erasmus Plus project. Proceed to the quiz to check your understanding, then continue to the next modules for more learning material.